Alright guys, welcome to today's video. So what we're doing in today's video is empirical and molecular formula part 2. But in this aspect, they're actually asking us empirical formula. Do you understand? But they are still under the same aspect. So that's what we're doing in today's video. But look at this question. It's somehow strange from the one we do in the first part. In the first part, we use percentage. Actually, I don't want to solve this to be our second quiz. I was looking for the aspect that they actually have. They actually give mass instead of the percentage composition. And if you have watched the previous video, if you have not watched it, make sure you check our YouTube channel to check how to solve empirical and molecular formula. You will see it in our previous video because that's the part 1 for this video. So if you have not watched it, go back and watch that video. In that aspect, we were given the percentage composition of carbon and hydrogen and oxygen for that type of question. They gave us that. Now this is it. There are some questions that they may actually give you instead of percentage composition, they will give you mass. Although I try to find that type of question, I could not see. The thing is, most of the times they actually ask questions using percentage composition most of the time, and that's what most students are familiar with. Yeah, right. Now, in such question, what you're going to just do is that in place of mass, in place of percentage composition that I taught you, you will be putting mass. It will now be mass over the molar mass of the compound, then you follow the rest procedure. Do you understand? Now, this question is actually different from the one we did. It's different from even just inputting mass. It's different. Now, they said a sample of a substance containing only C and H burns in excess oxygen to yield 4.4 gram of carbon dioxide and 2.7 gram of oxygen. They now said the empirical formula of the substance is, then they give us the molar mass and they give us the options. Now, whenever you see questions like this, you look at it, they already said the compound contains only carbon and hydrogen. Only what? Carbon and hydrogen. So let's write our solution. So this is our solution. Now the next thing we are going to do is, now the compound, let's assume the compound is CxH2y, right? They said it burns in excess oxygen to form what? To form carbon dioxide and water. But the thing is, we don't know the number of carbon dioxide that compound forms. We don't know the number of the mole. That is, we always have number of mole in this aspect. We always have number of mole in this aspect. We always have number of mole in this aspect. And at times, we always have here. But they don't tell us the number of mole of the compounds. That is, the number that will be in their front. And even this question is talking about empirical formula. We don't really need it. But what I just want to tell you is that whenever you see questions like this, and you don't know, they don't give you the percentage composition. The last time I taught you that you will do it like this, right? You will be saying this is your percentage composition divided by the molar mass. That is, this molar mass, you'll be dividing them by the molar mass, right? But this question, you cannot use this direct method, because if you look at the question, what did they say? They said burns in excess oxygen to form 4.4 grams of carbon dioxide and 2.7 grams of water. Do you understand? So whenever you want to do a question like this, it is different thing. Now they now say we should find the empirical formula of the compound of the substance. Now the thing is, this is what we are interested in. This compound. We are not interested in this. We are not interested in this. We are not interested in this. This is our main thing. If we are looking for oxygen, we are just wasting our time. That's not what we are looking for. Now, what you are now going to do is that since they have given you the total mass of carbon dioxide and they are giving you the total mass of water, now this is what you are now going to do. Let me now teach you. Now this is what you are going to do. You are going to look for the mass of this carbon in the whole of this carbon dioxide. The same thing with this hydrogen. Since it is hydrogen and carbon that we are looking for, we are looking for the mass of carbon and we are looking for the mass of hydrogen. Do you understand what I'm saying? We are looking for the mass of carbon Because if you know the mass of carbon, you can go and say, we have one formula in chemistry that says that mole is equals to what? Mass over molar mass. Do you remember? So once we know the mass of carbon and we know the mass of hydrogen alone, we can go and say the mass of this over the molar mass, then we will get the mole. And when we get the mole, we are going to know the empirical formula. I'm going to explain further now. Now let's do that. Let's look for firstly mass of carbon. Mass of carbon will now be equals to the molar mass of carbon over the molar mass of the whole carbon dioxide. Now you will now multiply it by the total mass of CO2. So that's what we are now going to do. The same thing for hydrogen. That's what we are going to do for hydrogen now. Now you first now ask yourself, what's the molar mass of carbon 4 oxide? So that would be that would be carbon plus oxygen, right? What is carbon? 12. What is oxygen? 16. But there is a subscript. You multiply it by 2. So what do we have? 12 plus 32 is equals to what? 44. Do you understand? So now what's the molar mass of carbon? Molar mass of carbon is what? 12 divided by molar mass of carbon dioxide. That's 44. Then you multiply by what's the molar mass of what's the entire mass of carbon dioxide? That is 4.4. So 4.4 divided by this, so you get 10, right? This in this, it cannot cut, but 12 divided by 10, that's 1.2 gram. So we have known the mass of carbon. Now we have known the mass of carbon. The next thing we want to know is the mass of water, mass of hydrogen in water. So the same formula that we use, we are going to use it again. Mass of hydrogen, the same thing. Mass of hydrogen is equal to what? Molar mass of hydrogen. Molar mass of hydrogen over molar mass of water times mass of water. So that's how to get it. Now what is the molar mass of hydrogen? Molar mass of hydrogen is what? 1, right? But look at it. Hydrogen here is 2, right? So you cannot be using 1 for hydrogen because your 1 will be 1 times 2. That will be what? 2. So the molar mass of hydrogen in the whole water is what? 2. So now that will be 1 times 2. What's the molar mass of water? So let's do that. Molar mass of water. So what is that? Hydrogen is what? 1 times 2 plus oxygen is what? 16. So what do we have? 18. So molar mass of water is 18. Now what's the mass of water? 2.3. So if you use your calculator, what are you going to get? You're going to get around 0.3 grams. So that's your mass of hydrogen. So we have gotten the mass of carbon. We have gotten the mass of hydrogen. The next thing we are doing now is finding the empirical formula. Now this question has talk about even what I want to talk about in the first part. Like if they don't give you percentage mass composition and you have mass, I told you that instead of what you are going to do is what you are going to follow the same procedure we follow. The first part I told you that you are going to divide the percentage composition by the molar mass, right? Then you are going to get your mole ratio. Then you divide by the smallest. The same thing we use in the first one, in that first aspect. That's what we are going to do here too. So let me rub the board. so we don't really need this again since you have gotten the mass of. I don't really want to rub everything. Let me try to just rub it strategically. So don't forget your mass of carbon is what? 1.2. So let me just manage this place. So don't forget, okay, let me just write it up. Now this is it. No, don't forget, mass of carbon that we got is what? What do we get? We get 1.2 gram. Mass of hydrogen, what do we get? What do we get? We got 0.3 gram, right? Now the next thing we want to do now is, now since we have gotten the mass, the next thing we want to do is, you now write the way I told you, the way we did the first one, that's why you do the second one too. So just do it like this: your carbon, your hydrogen. So just like the way we did the first one, instead of percentage composition, you'll be having mass. Do you understand? So even if they don't give you the way they give you the first way, you already know the way you do it now. So the mass is for carbon 1.2. So let's say our mass is in gram, so I don't need to write it here again. Mass of hydrogen, that is 0.3. Now the next thing we are doing is the molar mass. What is the molar mass of carbon? That is 12. Hydrogen 1. Then the mole ratio. So what is mole? Mass over molar mass. That will be 1.2 over 12, 0.3 over 1. So what do we have? We are still under mole ratio. So what do we have? 0.1, 0.3. So the next thing we are doing is what? Divide by the smallest. So can you see now, this thing is not hard. Divide by the smallest. So what's the smallest? 0.1. So that's 0.1 over 0.1, 0.3 over 0.1. Do you understand? So now what is 0.1 divided by 0.1? We have 1. 0.3 divided by this. I hope you can see it. Let me try to put it here. So 0.1 so 0.3 divided by 0.1, that's 3. Do you understand? Now the way I taught you in the first one, what is under carbon? That is 1. What is under hydrogen? That is 3. And I said this one is not really, so your empirical formula is what? So therefore the empirical formula of the compound, the empirical formula of the substance is what? CH3. So that's the answer. The empirical formula is what? CH3. So if you look at the option, what is the answer? So the answer is option A. So if you enjoyed this video and you watch it to this point, it means you are a very studious and serious student. And I want to implore you to subscribe to this YouTube channel so that when we drop interesting videos like this, you're going to have access to them. Thank you very much for watching the video, and I say goodbye.